Hi folks, happy Friday. In our last video, we talked a little bit about how all of these individual elements are organized. In today's video, we're going to continue breaking down the mysteries of the periodic table by learning how is the periodic table itself organized? Why are all of these elements in orange? Why were they put there? Why are they all alkali metals? What makes them be a category? Why have we put them together? That's what we'll be talking about. So I want you to think about family members that are biologically related to you. Are there any physical similarities between you and those family members? If so, what are they? Most people are going to have a decent number of similarities with themselves and their parents slash brothers and sisters, right? Maybe you've got the same hair color or the same type of hair, right? Maybe your hair is really curly and your parents' hair is really curly, or maybe your parents' hair is straight and your hair is straight. Typically, people's skin color is very similar to the skin color of their parents, as well as your eye color. If you have glasses or contact lenses, typically your parents also have or had glasses slash contact lenses. Um, there's a whole variety of different similarities that we physically have with our parents. And it turns out that there are a lot of elements in the periodic table that share a lot of similarities with other elements. And we call them families, just like yours. So I want to just take a little bit of time and talk about three families. We've got the alkali metal family, this little orange family right here. We've got the alkaline earth metal family. And we've also got this little family in red right here called the transition metal family. Now, these families are different. The orange ones, the alkali metals, they all explode whenever they're put in contact with water. And these elements in yellow, they're all really commonly used in things like batteries. And this larger family, this transition metal family, all of these metals have extremely high melting points. We have to heat them to incredibly hot temperatures in order to make them molten. So these are all like little families. Okay, go ahead and start thinking about members of your extended family, still people that you're biologically related to. You probably have some similarities with them as well, but probably not quite as many as your direct and immediate nuclear family. You might have an uncle who has different eye colors than you or your parents, but their hair color is curly like yours. Are there any relatives that you have in your more extended family that have similar physical similarities that you have? It turns out that the families in the periodic table are like that as well. See, our alkali metals, alkaline earth metals, and transition metals, as well as this family in blue over here, they make up the extended metal group. All of these elements, they're all metals. They all have some similarities, but not quite as many similarities as a single family has. It's like all of those cousins and uncles and nephews and nieces and second cousins and third cousins and aunts twice removed on your mother's side, that type of thing. That's kind of like how the metals are. Okay. So our periodic table is arranged in groups, like the metals group, and families, which are just smaller subparts of groups. So there are three groups to our periodic table. There's the metals, which are these elements in orange, yellow, red, blue, and technically these two down here, the lanthanides and actinide series, they're also metals as well. Then there's this kind of light blue group. These are called the metalloids. Metalloids are almost metals, except not quite. They have kind of similarities, to metals, but they also kind of have similarities with our third and final group, the nonmetals. Okay, so the nonmetals are this group in green right here and this last little group in purple called the noble gases. The noble gases are a particularly interesting group because the noble gases don't react with anything. In fact, you're breathing in a little bit of all of those noble gases in purple right now. But because they don't react with anything, you and your body never notice them. They just kind of hang around. Your body's also breathing a lot of the elements in green right now. Lots of oxygen, nitrogen, and tiny trace amounts of things like fluorine and chlorine, but very little atomic levels of those. Okay. So we've got groups like the metals group, the metalloids group, and the nonmetals group. And we've also got families like these subgroups. Okay. And the reason that all of these elements are put together is because their families and their groups have similar characteristics. That's why they're close together. Just like you and your family is close together. Pretty cool. Science. We will continue to unravel the mysteries of the periodic table and how to use it and how it works. This is such an incredibly powerful tool. I can't stress that enough. All right. Until next time, folks, have a good one. Bye.